Part-to-whole versus part-to-part ratios. We will use another example to illustrate the difference between these two types of ratios. Example 1. A company has 120 employees where 45 are male and 3/5 of female employees have attended university. A. What part of the staff are female? B. How many women from the staff have attended university? C. What part of the staff are female employees who have attended university? D. What is the maximum number of groups that can be formed by preserving the same gender and education structure of the whole staff? Solution 1. A. The number of female workers in the company is 120 minus 45 is equal to 75. This number makes the following shown on screen. B. We have 3 out of 5 women from the staff who have attended university. Thus, the total number of female staff (FU) who have attended university is shown in the following on screen. C. The previous number divided by the total gives the part of the staff that are both female employee and have attended university. Thus, we have the following shown on screen. D. The number of male employees is also 45. This number makes 3/8 of the staff, as found previously. Therefore, a group of 8 people must contain 5 women, where 3 of them have attended university, and 3 men. This is the smallest group we can form by preserving the original structure of the company staff. Therefore, the maximum number of groups possible is shown in the following on screen. Scaling up ratios. We can use the ratio between 2 or more quantities given in the simplest form to find other equivalent ratios. This can help us find the number of elements in a group. We saw this property when explaining ratios expressed in a number line, where we could find other ratios besides the required one by looking which numbers were aligned vertically. This time, however, we can use not 2 horizontal separate axes placed one under the other, but 2 perpendicular axes instead, which allows us to draw a straight line which gives all possible relationships between the quantities involved through a straight line drawn from the origin. The advantage of this method known as scaling up ratios consists in the fact that we can obtain a larger number of possible combinations between the quantities involved, which follow the rule given in the ratio. However, it also has a disadvantage: we cannot include more than 3 quantities in the calculations, as the maximum number of axes we can use is 3, the space is 3D. From algebra, it is known that if 2 quantities, we often call them variables, as the values of one quantity affect the corresponding values of the other, are in a constant ratio. The line that shows all possible relations of the 2 quantities, we call it the graph of relation, is linear. The best feature of this method consists of the need for only 2 corresponding values, one for each quantity. These values act like coordinates of the graph, expressed by number pairs. Then, we can draw a straight line that connects the origin and the given point expressed by the above values, coordinates. This line can be extended further in that direction to obtain other pairs of numbers. Example 2. A factory produces hats and shirts in the ratio 3:4. A. Plot a graph to show this relationship. B. From the graph, find the number of shirts produced for every 21 hats. C. Again, use the graph to find the number of hats produced for every 24 shirts. Solution 2. A. We express the hats on the horizontal axis and shirts on the vertical one, all this in a millimeter paper, as the one shown previously. Since for every 3 hats we have 4 shirts produced, then for every 30 hats there are 40 shirts produced. In this way, we use the pair 30-40 as a reference for our graph which starts from the origin. Then, we continue further in that direction. We have the following shown on screen. B. If we look at the graph carefully, we notice that for 21 hats there are 28 shirts produced. This is because the point 21, 28 is a point of the graph. See, again, by observing the graph carefully, we notice that for 24 shirts, there are 18 hats produced. This is because the point 18, 24 is also a point of the graph. We have the following shown on screen. As you see, if we have the graph of a ratio plotted, no further calculations are necessary. We can find all values needed by looking at the graph. That is all for lesson 4.1.4. To continue this tutorial, please watch 4.1.5, finding the new ratio when one quantity changes. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.